All right, thank you so much, Jonathan, and thank you to Boaz, Stevie, and the whole ICT team for hosting this great event. And thanks, of course, to my good friend and colleague Asaf, who will always be a member of our CTC family. Always great to see Asaf. And General Lute, always great to follow a fellow member of the Lincoln Hall Brigade from Soch. So pleasure to be up here. First, I must beg your forgiveness. So I'm recovering from a bout of laryngitis, as you might pick up in my voice a little bit, a little rough. As of 2 days ago, I could not speak a word. Before anybody gets concerned, I've tested negative multiple times, okay? No, rather than COVID, this is the result of my side hustle as a coach for my son's football team. Apparently my coaching style is, well, a little loud, I think. To be clear, I grew up in the British territory, so when I say football, I actually do mean football, not our American variation. As a side note, if anybody here has an extra ticket for the Maccabi Haifa PSG game tomorrow night, I'll be outside afterwards. If you want to discuss research collaboration or whatever, I'll be there waiting. Okay, when practicing last night, about 10-15 minutes, my voice gave out, so we'll see how this goes. I think my vocal cords are going to beat the clock. We'll see. But let's jump into it. So I want to start by saying a little bit about my organization, the Combating Terrorism Center at West Point. For those of you who don't know us, we're a research organization focusing on terrorism and counterterrorism that is based at the United States Military Academy in West Point, New York. See, 2 minutes, we're already struggling. Okay. Hopefully, many of you have come across our products in the course of your work or studies. In addition to the teaching we do for our cadets and the amazing research program managed by our great Daniel Milton, who is here today, we also publish the CDC Sentinel, which hopefully many of you know is our monthly publication and journal. I'd like to talk today about the Sentinel and specifically about the great work that has been done recently in that journal. First and foremost, huge kudos to our fantastic editor-in-chief, Paul Cruikshank, sitting back there, and the equally amazing Chrissy Hummel, our managing editor. Every month, I simply marvel at the fascinating work that they put in front of us and the rest of the board, and myself and the rest of the board for review. I also want to highlight the recent partnership that we've initiated with Boaz, Stevie, and the ICT team to commission a series of articles and interviews examining terrorism and counterterrorism issues here in Israel. The work so far has been excellent, and we thank you, Boaz, for your continued support and collaboration in this awesome effort. So, at the Sentinel and the CTC, we've always worked hard to publish scholarship on terrorism and counterterrorism that is, as we say, objective, relevant, and rigorous, as we put on our masthead. I want to highlight one particular Sentinel project that we recently completed that I think really kind of is the perfect example of bringing together these three ideals. In April and May, we published a 2-volume set of special issues examining the biological threat, which is a topic that I haven't heard much talk about here this week. So I want to highlight that. The origins of this project speak to its relevance. We at the CDC had already been having numerous internal conversations about how to better examine the impact of the COVID pandemic on broader terrorism issues. And we also have an ongoing partnership with West Point's Department of Chemistry and Life Sciences, with whom we had conducted some research examining terrorist use of emerging technologies. The final pillar, however, was when one of our key partners in the U.S. Special Operations community reached out to us and expressed an intense interest in more and better research examining evolving biological threats. So when you have a topic that both academics and operators are intensely interested in tackling, I think that's a pretty good recipe for a successful and relevant effort. In terms of objectiveness and rigor, we recruited an amazing multidisciplinary team of authors and interview subjects who represented a diverse mix of practitioners, government officials, scientists, terrorism specialists, and military officials. This includes, I should note in this setting, an interview with Dr. Shmuel Shapira, an ICT Senior Research Fellow and former Director General of the Israel Institute for Biological Research. Collectively, this group produced a fascinating series of articles and interviews that really objectively tackled a broad range of issues related to biological threats and bioterrorism. The resulting products gave our operational partners the rigorous research that they were looking for to provide useful context for the critical work that they do every day. So what I'd like to do is provide a brief summary of some of the key perspectives and findings that were offered up in this project. And I'll start with a conclusion that the overarching challenge is the same as it is for most other emerging technologies. And that is that we have to find an appropriate balance between opportunity and risk, right? So almost all of these technologies, whether you're talking about IT, communications platforms, or UAVs, or 3D printing, or synthetic biology, much of which we talked about some of these technological innovations earlier this morning with our UN partners. All of these things are being developed for the right reasons and present us with significant benefits for society. But they all also pose potential risks if put in the wrong hands and for the wrong purposes. So what are some of those risks? The research we published really highlighted a litany of advancements in the biological field that could have dangerous implications in the security space. One of the most notable developments is the CRISPR system. There's an article by my West Point colleagues, Colonel John Burpo and Major Stephen Hummel, highlight how with CRISPR, one can, with relative ease, design and manipulate specific target sequences to modify, insert, or delete portions of genetic material. This would allow a prospective bioterrorist to select a virus of choice and then genetically modify viral transmissibility, incubation and infectious time windows, and lethality, creating what is essentially a tailored or even a tunable bioweapon. These weapons can be designed to achieve specific target effects at the tactical, operational, and strategic levels. As Dr. Lawrence Kerr, a former senior White House medical official, said in one of our interviews that we published, "If you give me the exact requirements for what you want to do to someone or a group, do you want to incapacitate? Do you want to kill? How many? For how long? We can design you that pathogen. That is the power of biology." He points out that while our defenses have also made great advances, just a single point mutation can make highly effective vaccines and therapeutics essentially useless against a new, highly resistant strain. At the heart of most of these issues is the dramatic intersection of biology and technological fields, such as computer science, automation, engineering, quantum mechanics, and so on. Audrey Kurth Cronin authored an article for us where she addressed this concern, pointing out that the intersections between these areas of study are reshaping the entire landscape of what biology is, which in turn changes our focus regarding what a biothreat in the 21st century could look like. She concludes that the most dangerous threats are coming not just from biology, but from the intersections between disciplines. Cronin also, really in a fascinating way, highlights an example from earlier this year of a US company that did an experiment with its tool that uses computational machine learning to discover new drugs for rare diseases. While their tool is designed to reject anything predicted to be toxic, the experiment was actually flip the parameters of their model and instead favor rather than avoid toxic molecules. What could go wrong, right? They expected this experiment to produce gibberish, but instead, to their surprise, the AI took less than 6 hours to design not only a VX nerve agent, but also novel, even more toxic agents that weren't even in the training data set that the tool was using, for a total of 40,000 new possible weapons. Another key concern has to do with the rapidly growing so-called do-it-yourself or DIY bio-community and biohackers. While traditional researchers typically have adequate management and review structures around them, that is not the case for the unfunded DIY community. As Cronin points out, the barriers to entry have decreased. Bacterial gene engineering kits can be bought online for $169. You have whole genetic engineering home lab kits that can be purchased for less than $2,000. There are international competitions for students to create novel products using synthetic biology. And overall, most of these are good things, right, in terms of scientific education, but not everyone gets the necessary education in how to use ethical guidelines for using this technology. And experts don't even agree on what ethical oversight of biohacking even is. In general, as all types of research in this space have increased, so does the risk. As our article on bio-risk management by Lentzos, Koblenz, and Rogers points out, after every recent significant outbreak, to include H5N1, H1N1 back in 2009, the 2014 and 2016 Ebola outbreak, and of course COVID-19, as we saw in all of these, after them we saw significant increases in research that potentially has security implications. For example, this includes deliberate development of novel viruses for use in so-called gain-of-function research. These are essentially those tunable weapons that I was talking about, where a specific virus is designed to enhance its lethality or transmissibility. We also saw an increase in field research in mobile labs, which, while helpful in an outbreak, of course, also raise the possibility and create opportunities for the risk of accidental or deliberate contamination. The overall increase in labs and scientists working on these dangerous pathogens has created more opportunities for these agents to be stolen, particularly by insiders. Even the more established labs are also at risk. A 2021 survey identified that only 6 out of the 23 countries with maximum containment labs were scored as having high levels of biosafety and biosecurity. It's a pretty troubling finding there. And then, of course, there's the private sector, where there are far fewer requirements for review of dual-use potential. As our authors point out, given the increasing size of the global bioeconomy and the growing commercialization of products generated with synthetic biology and genome editing tools, the exclusion of almost all of the work done by the private sector from dual-use research oversight is an increasingly large loophole. There are also risks related to the publication end of research. In our interview, Dr. Shapiro discussed the importance of responsible science. In addition to safe labs and facilities, he also emphasized responsible publication, highlighting the dangerous nature of some past publications, including articles by researchers on how they manipulated the avian flu virus. At the end of the day, however, the benefits of all these advancements are so great that this revolution in biology will continue. As Brad Ringheisen, a former senior DARPA official, pointed out for us, we cannot not use this technology to help society. The benefits are just too many. We could save lives. We have to use it. So the question then is, how do we use it safely? How do we try to set up the guardrails to be able to use it safely? Before we examine the specific guardrails, it's important to recognize that the impact of this revolution in biology has played out in a similar way as past WMD or CBRN threats, in that people express significant concern simply because the worst case scenario truly is so awful. However, a more sober assessment takes us to the conclusion that this stuff is hard. It really is. Several of our authors made this point about the criticality of the correct expertise. Burpo and Hummel emphasize that while the availability of these new tools reduces many technical hurdles, substantive modification of a virus still requires considerable knowledge of the virus and the desired outcomes. Ringheisen also emphasizes that biology is complex. While going in and making a change in the genome is, in theory, much easier now, it's very difficult to reliably achieve a specific desire or outcome, a specific desired outcome. Whole teams of highly trained scientists are working on how to deliver the reagent to the specific cell, which is a tremendously difficult challenge. He concludes that it's impractical to think that one person with malintent will be able to make enormous strides in doing something very nefarious in this area. That said, all of our authors also cautioned that advances in technology have made it the case that certain required steps are much easier than they were in the past. So the takeaway that we should really get from this is that while we should not conclude that the sky is falling right now, we should very much keep our eye on this space to ensure these advancements are handled ethically and responsibly. The research we published highlights a wide range of steps and measures we can take to mitigate these threats and concerns. Too many to articulate in the time left here, so I encourage you to go check the articles out. But I'll highlight one broader finding, which is that the policy focus and funding for work to address these issues has evolved in much the same way as CT funding has over the years, meaning that it typically comes in fits and starts, depending on the perceived threat. So in the US, one of the key frustrations that we've seen is that a lot of work's undertaken to develop new strategies, new plans, but the funding doesn't follow. As Dr. Kerr pointed out for us, strategies are pieces of paper that sit on bookshelves until they are actually funded and turned into programs that can operationalize these plans. The final point I will cover has to do with the impacts of the COVID-19 pandemic on the field of biotechnology and specifically the threat of bioterrorism. Almost all the authors in our project highlighted various lessons learned from the pandemic. We saw successes, we saw failures. Learning from the failures will surely improve our response in the future. And heavy investment in research and technology has led and will continue to lead to significant advancements in the field. In terms of impacts on bioterrorism specifically, we published a fascinating article by Ackerman, Kallenborn, and Bleak that created a taxonomy of bioterrorism and then assessed the impacts on this taxonomy of the COVID-19 pandemic. They consider these impacts across four aspects. One, terrorist interest in bioterrorism. Two, the capabilities of terrorist groups to carry out bioterrorism. Three, impacts on the consequences of bioterrorism. And four, impacts on our perception of the threat, vice the actual threat itself. In the interest of time, I encourage you to go dive into the piece and check it out. For now, I'll simply leave you with our bottom line conclusion, which is that COVID-19 will have a limited overall effect on bioterrorism risk, though it may have greater effects on perceptions of those risks. So I'd like to conclude by saying this project is indicative of the kind of work that we at the CTC are really hoping to produce moving forward. We are not a large shop, and we can't be productive without critical partnerships with both our US government partners, but also all of you. So I know many of you in the conference have already contributed to the Sentinel, and I encourage the rest of you to try to do so in the future. We really rely on that input. If you have ideas or proposals that you would like to work on with us, please come talk to us, come after the conference or in the break, whatever, or reach out to us in the future. In this environment of continuing threats but diminishing resources, it's only through robust collaboration that we can continue to make important progress in this field. All right, I think my voice made it, and I got 30 seconds left, so we're good to go. Thank you very much, everybody.